All right, guys. Well, I'm especially excited. I think we were going to do this panel in Spanish because we're in Buenos Aires, but that's a good thing that we decided not to do that. These panels, oftentimes, we kind of get into the technical weeds, but I think there's something that happened just this morning that everyone can relate to, which is that Cloudflare went down. A few weeks ago, AWS went down, and there was blockchain outages as a result of these Web 2 technologies suffering. And I guess that's my hot take. I'm going to ask you guys for your hot takes, but how can we possibly preach decentralization and disintermediating these companies and building a new, better web if we're still relying on the same technologies that continue to break over and over and over again? Guys, what is your hot take and what is the solution?
I think that the best approach that people is doing, at least for this outage, is like if you want the network to keep running, if you want your data to be available, it's that you just need to try to run some things locally. So for us at 0x, it will be like running nodes on our own. So if there is an outage somewhere, we have fallbacks and we can like use our own nodes and keep and have the data available, have everything. So try to be as less exposed as possible to all of that outages.
Yeah, hi. Thanks for having me. That's a very good question. I guess the infrastructure today is extremely centralized. You have like three big players and they have like 99% of whatever is going on Web2. So whenever one of them is down, everyone is impacted. And I think like one way to try to fix this is to build apps that works on more decentralized infrastructure. So people would be able to run their nodes, connect on their computers at home, and they would be part of this network that would be processing transactions and doing stuff. And I guess that's all about like Bitcoin when it started initially. So even though you said that Cloudflare was down, AWS was down, Bitcoin was up. Most of our networks, they were impacted because they are decentralized. So only the centralized ones are really impacted by these really big infrastructure issues. Because companies are moving to these places, but if they think like a way to move this to their clients, so people would have those things running on their home, that then no disruption would happen, even though these big data centers can be bring down.
So even when AWS went down, some of these blockchains did still go down, right? So I saw some L2s on Ethereum.
Yeah.
So I'm curious, what exactly was the piece of the technology stack that crashed? When AWS, what is the piece of the blockchain stack that is linked to AWS?
It's like for L1s, it's the validator set, or for L2s, it's the sequencer. And I guess the problem there is that for L2s, unfortunately, the reality is that the sequencer or sequencing set, it's much more centralized. Like every L2 tries to keep their cards to themselves. For validators especially on Ethereum's, luckily it's kind of like it's slightly different. It's not perfect. But I'm actually here to talk about Compose, which is a new product. But reality is, I work for SSB Labs, which is the sort of company behind SSB Network, and this strikes home a lot because what we do is a distributed validator technology. It's basically, you can think of it like a multi-sig for validators, and this means that basically you can create key shares for your validator key, and 4 to 7 or 10 different machines can run like multi-sig for your validator. So it means that your key is distributed, and how good you distribute it, that's up to you. But like this is more of a a job for us to advise on people running their infrastructure as best as they can. And to our credit and the credit of our partners and people that don't run with us, most of them do. They still do heavy usage of AWS and the sort, unfortunately, but there's a lot of bare metal. There's a lot of also other initiatives like Lido does Simple DVT, which is like an initiative that involves home stakers. And it's very painful and manual project to select and do a mix and match of, let's say, a cluster of 7 that has 2 professionals that likely use AWS. We got a few niche node operators that maybe use bare metal, and then we can add in like 3 home stakers that have either a home setup or one of the NUC machines. And this way you can basically like, you're safe and secure that you're going to have a good performance, you're going to be stable and everything, but at the same time, you're protected against these events. I think Lido has been doing a good job with this initiative, but at the same time, it demonstrated the feasibility, and other big partners of ours, like copied, mimicked the idea, and sort of like started doing the same. Like we have partners like Kraken. Obviously, in their case, they want to, maintain. They don't want to pay other operators to do it. So they do it themselves. They launch the nodes, but they mimic the idea of like cross-pollinating, having machines on different continents and so on. So there are ways to protect against it. Unfortunately, it's not like, I would say, the industry standard yet, and especially with L2s and small networks.
Yeah, I like just to add that he touched on a very critical part. That's the validators, and validators usually they're extremely centralized today for one reason: scalability. So as decentralized networks have like a hard time to scale, the solution that layer twos have given is like, let's have everything running kind of in the same place with high bandwidth and like minimum hardware so they can process all the transactions. But then they're moving to these data centers and they are highly impacted when then something's down because they are not decentralizing, they are centralizing. In essence, they are not very different from the credit card companies. They can process hundreds of thousands of transactions per second, the credit card companies. And this guy is like in a data center with low latency, high bandwidth, they can do the same. Of course they can. I guess the challenge is like how to get scalability to a very decentralized network. And that's like a challenge. And that's why one of the things that we're trying to approach with our new technology that we're launching, nano contracts, one of the points there is scalability, like to try to bring more throughput, higher throughput for the really decentralized networks. And then in that case, the even if AWS is down, the network keeps working.
These are the days like today where maybe they only happen once or twice a year, but this is what separates the projects that survive for the long run versus the projects that don't. And I'm curious what other pieces of infrastructure you see as crucial, critical to the stack that maybe is flying under the radar right now. People aren't paying enough attention to what part of the stack. Because right now, I think RPCs are extremely centralized. Both of you guys mentioned validator sets, extremely centralized. If I were to go ahead and start, we talked about how the L1 validator set, they can use bare metal, they can use home stakers. You talked a lot about that. There's no alternative right now for L2s that use a single sequencer that is totally centralized. There's no other alternative right now in production. So that would be one example that I think we really need to pay a lot more attention to. We need to focus a lot more on improving that piece of the technology. What other pieces of the stack do you think are really, really crucial so that the entire industry will sustain through the periods of downtime? When Web 2 is down, Web 3 continues to stay up because we focused on these parts of the technology stack.
Yeah, I'd say that there's a big challenge in the front end with the dApp, because even though we have the decentralized blockchains, let's say like that they're using decentralized, not like centralized validators. So the blockchain keeps live, but if the front end's down, people cannot access it, and most people they don't know how to go straight to the blockchain. And these front ends they are very centralized too, and many of them they rely on backends which are centralized as well. So it's not that like the dApp is only interacting with the blockchain, but the dApp is interacting with a middle layer that is centralized. So decentralizing the dApp, the front ends, I guess it's part of the challenge.
Yeah, I was going in the same direction. I was going to say indexers, which are basically, kind of like a data availability layer, but their biggest use case is front end. Like you can literally build the dApp on an indexer instead of having like a I don't know, a custom made backend, which is still web hosted on Web2 services, etc. There's not enough wide usage, in my opinion, of indexers for building dApps. And there's not enough, I would say, really truly decentralized protocols for indexing. Like, because at the same time, like there are good examples, but they're either not widely used, or they don't have, I would say, the economic uh, set of incentives to really truly be decentralized.
Anything that
No, this is a very interesting point. Like the websites, the UI, all of that is also hosted on AWS or places like this. But I think that there are solutions for that nowadays, like hosting your website in a decentralized storage solution.
Yeah. Like I don't know. In an
And
ideal,
but I
in an
think that
ideal
that is
world,
not that much adopted.
yeah, exactly. Like
So
in an ideal world, you could technically take your somewhat static page and host it on IPFS, and it can be executed from there. Like you download it and visualize on the browser from there, and you can just like make web calls to your indexer. This is like how to build a fully distributed and decentralized front end. Feasible. Not everybody or very few people do it, in my opinion.
Yeah, and they need to think about dApps in a way that the front end doesn't depend on a back end.
Yeah.
Unless it's like the full node, because if there's a middle layer, that the middle layer is still centralized.
Exactly, for whatever fresh data you need. It's just like you have the RPC and then full node, and you
So
go.
if the dApp talks only with the wallets and with the full nodes, then I'd say it's a really decentralized application. But most of these so-called dApps, they have like a backend infrastructure, which is centralized and would be a problem in this case. Even if you can deliver the like static pages, they won't be able to run because they depend on services that are not available, that might be not available. So if you move the services to the full nodes, so if they run inside the full nodes, then you cut down this middle layer. And if it's really decentralized, it just points to another full node that's not down, or the one that you have in your home, and it simply works.
there is another crazy thing is that most of all our teams are hosting our code in GitHub or platforms like that. And so our development flow depends on GitHub a lot. And if platforms like GitHub have issues, outage or whatever, it's very complex to continue doing the stuff in the regular way that you do it. So that's another problem. I think that there have been people thinking and considering about decentralized solutions for GitHub, but I don't know about anyone that is like being used right now. Everyone is still on GitHub, and we are not doing anything for that. But yeah, that's another centralization case.
all of these efforts to make these things more decentralized tend to add complexity. And so I wanted to ask you guys how we can continue to work in this direction, make these things more resilient, less dependent on some of the existing infrastructure, but also bring down the barrier of entry for new developers. They're used to all of these tools that they're coming from AWS and all of these things. And it's an entirely new world, not just for end users, but for developers as well. How do you guys think we can simplify the technology stack or the access to these tools so that we can continue to onboard more and more developers? Another way to ask this question is essentially, if you were getting started from scratch today, coming into the ecosystem, where would you start?
I don't know about this last question, but like to answer the first part, the thing is, you brought up the reliability, for example. I don't think you used that exact term, but like much of the reason why what we just said is not actually adopted is, for example, yes, I'm using an indexer protocol to use for the data availability of my DApp, but if they don't have the right economic incentives, at any moment, for example, it stops being profitable for a node to index my data, and all of a sudden my web app, my DApp is not served. So like it stops working, and unfortunately, like even if there's like catastrophic scenarios that we just discussed with Web2, it's you have somewhat like someone to blame. I think that is kind of important where, you have a AWS call center and you say like, what the fuck is happening with you? With a distributed protocol, you cannot just like call, I don't want to name names, but you cannot call the protocol X in question and say, "Where's my data?" Oh, sorry, like it stopped being profitable for people to index your data. So that is, I guess, the danger. It's somewhat the fluctuating nature of the economic interest that makes it unreliable. You don't trust it. You don't want to like put all your eggs, and also it's kind of like a lockup. It's very easy in a way to, in my opinion, to transition from AWS to Azure. Because at the end of the day, if you do Kubernetes architecture, you just like change the location, but remains the same. Whereas with many of these protocols, you have somewhat of a lockup where you have to change your code base to do slightly different API calls to the new service that you do. And so it's a barrier. And so you don't want to go there for that reason. So there's this things to tackle, but I don't have a solution. I'm afraid. Growing pains, I would say. I don't know.
Yeah, the solution is always build crypto native technology. That is very complicated sometimes, and we inherit Web2 technology, right? So every time that we use it, we are going to have dependencies on Web2 infrastructure and stuff like that. So the solution is just build crypto native stuff, but that is very complicated. And sometimes just because you are launching something, you don't have like all the time in the world to build something that is fully crypto native, and you need to go to the market, you need to sell your product or something. So it's very complicated. But I don't have a solution to to offer right now.
Yeah, let me add to the second question about where to start. I guess one of the big challenges for developers from the Web 2 to come to Web 3 is that the execution model is different. They have an execution model of how a computer processes this, runs the software and process information that's not really true. It's not exactly the same on the blockchain. So it's very easy to make mistakes that they can't see, even though it's there. So I guess it's a big part of the thing, and that's something that we are trying to. Because today is a huge day for us. We are launching our own smart contract platform. It's called Nano Contracts, and the main goal of Nano Contracts is to be friendly with devs, so they don't need to really understand what's going behind to build like safe code. They can build their contracts in Python, so it's very familiar language. You're not bringing a new language to the table, and the execution model is very close. So you can say, oh, but it's more limited than what can be done in other networks. Kind of by default, yes. So we have like, I guess, good defaults for programmers, but they can allow more complex and sophisticated stuff to take place. But they need to explicitly allow if they don't even know that this thing exists. So I'll give an example. Many of the issues in Web3, security issues that happened recently, are related to reentrancy attacks. So reentrancy is a thing that can happen very easily in a blockchain, but in a regular Web 2, it can happen, but it's very hard to happen. So you have lots of control about that, but not on blockchains. And by default, reentrancy is not allowed. So unless you know what reentrancy is, it's part of your business model, and you want to allow reentrancy, devs are protected. So I think like a good way to welcome, so to wrap up, a good way to welcome Web 2 developers in the Web 3 world is to give them tools and a set of an execution engine that's really as close as possible to their own world, so they can start building immediately. So I guess, yeah, that's it. It's all about how familiar things are for developers. And today, I guess, to start on Solidity and to build like something that's production ready, oh, it's a long way.
Something to
I
no?
just
Yeah,
thought of like, because it reminded me about the second part of the question, and I thought about like the work that we're doing with Compose, which is essentially to tackle I think it's very fitting with the conference, which is Multichain, which is in one way the expansion from Ethereum from L1 to L2 is great, but it created a situation where it's all fragmented, the liquidity is fragmented. You want to access something that is on another chain, you have to bridge, wait. There's a lot of like delay and a lot of like trust assumptions. So what we try to do with Compose is like tackle that problem, and essentially the goal is to abstract away all of the L2s and make one like coherent ecosystem where you don't even have to know in the end if the contract that you're trying to access is on the chain where you start or is somewhere else, because you can access it instantaneously, atomically, and with synchronicity guaranteed by our protocol. Essentially, we have to go a little bit into detail if I have little bit more time, but we took what Espresso did with Circ and with their idea of mailbox contracts that allow sequencer to sequencer communication. We did our own spin that kind of like took away one of potential point of failure, which is their approach with a shared sequencer. We maintain the sequencer sovereignty for rollups, and we have a shared publisher, which is it's going to be connected to the validator set that we have on SSV, and so it's going to be distributed, which is adding another point of distribution. At the end of the day, what this means is that when you have a transaction going from rollup A to rollup B to do something else on rollup B, the two sequencers talk to each other, simulate it, and make sure that the calls cross-chain calls are matching on the two sides, and they can either all be accepted and executed or all fail. So it gives you the atomicity, like the pre-execution simulation is what gives you this guarantee. And basically, it gives you the same composability that you have on Ethereum L1, where you can make, not with contracts, but we're doing at the moment with user operations, so account abstraction. You can essentially compose multiple calls and create a complex user interaction that is still atomic. And so I think this is a great step in the, let's say, not necessarily, yes, like at the end of the day, user experience, but also developer experience, because it gives you a lot more power in leveraging what is being developed in the entire L2 ecosystem, not just one.
To go back in history a little bit, this was the solution, or at least the proposed solution to the Ethereum fragmentation problem, right? When we started to go modular and go multi-chain, Ethereum started to go and take the L2s and the rollups as the front of the user experience. It caused this fragmentation problem, and then we said we have to bring all of these chains together. My question, and maybe we'll start and we'll work this way. My understanding is that yes, this would be a great technical solution, but the incentives are difficult to align rollups or chains or L2s or L1s into the same validator set or into the same sequencer rotation. Then, right now, this is how the rollups are making money. They're making a lot of money base. Arbitrum, a lot of these rollups are doing quite well because they're retaining the sequencer revenue. Therefore, they're very reluctant to give that up. So general question is, what are some of the ways that we can solve these incentive problems? Like these technical solutions, we have these things that exist in our mind because, we're all thinking ahead and thinking as engineers, but sometimes the business economics don't align with the technical solutions. So when you're thinking about this, maybe business goes one way, technical goes another way. How do you bring these two together?
So, I think that a lot of it has to come from the community itself and the users. Like they have to put their, their interest first and ask for changes eventually. But also, it will come with the facts. Like, I hope I'm not being too naive in imagining this, but if we succeed in the way we want to succeed, the borders between L2s will become blurry to the point where it's virtually indistinguishable what rollup you're interacting with. And so your capital can be in your, chain of choice because of reasons maybe I'll get in a second. And then you can interact with anyone and like any other rollup instantaneously. So you essentially don't care where capital is. You just keep it where it fits more of your interest. And in my opinion, it's where it's more secure. So the security model and the security I would say, principles of the rollup where you keep your stack, it becomes more important than how fast it is, how the throughput and everything, all of the things that we think the users wants right now, but we're cutting corners to get there, right? So when the borders between rollups become blurry, then where you keep your capital becomes more important, and that's when the decision of, oh, actually that rollup has a more distributed set of like it opened up the sequencers to not just a single one. It's more secure. Maybe I'll keep my capital there, right? For example, or I'll keep it on L2 because it's easy to transition from L2 to that all of the other rollups.
Yeah, I'll add in two fronts. I guess one front is that the validators today, they are the incentives there. They are like, you have a stake, you put your stake there, and you have to be online all the time. So if you're down for any reason, you are punished. And I guess we need to find an alternative to that, because that makes the validators, even though they need bandwidth, they need low latency, that concentrates a lot because people delegate to others their stake because they don't have the infrastructure at home to have the validators really running there. So I guess one big challenge is to really have like a different validator protocol where it assumes that nodes can be down more often, that a higher latency is going to take place there. So people would be able to run the validators in their own home using their regular computers that fails eventually, and networks down, energy is down, lots of issues anywhere, but they don't get punished if something bad goes. Because this thing happens. So nowadays, I guess we are we have like an incentive to centralize validators because of this punishing mechanism in the proof of stake world. And I'll add like that another relevant part of this equation of incentives for developers, especially, and connecting to your question about Web 2 to Web 3, how to bring developers is like to provide a way to monetize the developer, the guy who creates the contracts, because these guys are making codes and make this code available at GitHub for free, even though there's licensing, there's lots of stuff. If we find a way to monetize the developers on chain, they would have way more incentives to come because they can make money out of it. So, and today I can't see any solution or anyone trying to fix this challenge about like how to monetize the contract creator, the coder, the developer. So I go like, but I agree, like these incentives, they are quite challenging, and finding the right balance where it works, it's super hard.
Fragmentation is inevitable, I think. So there is a lot of very good teams out there building different stuff. So liquidity is going to be fragmented. It's going to continue being fragmented. You can see that there are a lot of chains. There is liquidity in each chain. In every chain, there are a lot of dexes, centralized exchanges. There is a fragmentation there. Even now in DEXs, you have different hooks managing liquidity in different ways, so more fragmentation. So it's very, very hard to avoid fragmentation and align everyone, all the teams, to get all the teams aligned. It's very complicated. And I think that it's not going to happen because everyone is innovating in their own way, right? So I think that that is the work for us aggregators to add a layer of abstraction on top of that. That is what we do. So basically, you can have the liquidity everywhere, and we are just going to blur all the fragmentation for you. So what do you want? You want to do a swap? So let us figure out how to give you the best execution of the swap that you want to do. And this also scales to bridges. So bridges also contribute to this fragmentation because you move the assets from one place to the other, and it's not a standard how they do it. So that is, for example, one of the next things that we are going to offer. So we are also trying to solve the problem of fragmentation from moving from one chain to the other.
This is one of my favorite cross sections of the industry, is where the technical and the business incentives, where they converge. And we have to make very thoughtful decisions about how to navigate that cross section. Give it up for our panelists. This has been great. Everyone, round of applause. Thank you so much.